free training provided by the HVAC School podcast is made possible because of the generous support from our sponsors, Testo, Rector Seal, and Carrier. Now, I'm a huge fan of Testo. I've been a huge fan of Testo for years. I was a huge fan of Testo when the 550 first came out, and we used it, compared it to some competitive devices, and I just fell in love with that product, the Testo 550 manifold. And then from there, they came out with the Testo Smart Probes, and I really started getting more into airflow measurement. And one product that I'm really excited about is the Testo 420 airflow hood. The Testo 420 is really an industry-leading, fully functional airflow hood, and it does a great job in both commercial and residential applications. It has flow straighteners inside of it. It has a high-quality manometer that you can actually detach from the flow hood itself, the Testo 420, and use it separately, which is a great feature. You get a lot of bang for your buck with the Testo 420. It works with the Bluetooth app, so you can actually log a job when you're doing a test and balance on a job. So it just has a lot of really great features. It's very light. It's very easy to handle. That is the Testo 420 flow hood, and I have tried it out. I actually did a video of how to set it up and how to use it on the HVAC School channel. If you want to find out more about it, go to TrueTechTools.com and then just type in 420. Find the Testo 420 on TrueTech Tools. If you want to buy a 420, you can get a great discount by using the offer code GETSchooled in the coupon box that's down on the left side when you start to check out.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
And now for the guy who sheds a tear and whispers, "Freon ain't free," every time he finds a leaking braze joint on a warranty call. Bryan Orr.
Yes, this is the HVAC School podcast, the podcast that you listen to remember all the things you forgot about the HVAC and refrigeration industry, and maybe remember a few things you forgot to know in the first place. I'm Bryan, and I always want to call this the HVAC School radio show, because I always wanted to have a radio show. I listened to a lot of talk radio when I was a ute, when I was a teenager, and then up through my formative years. I actually used to listen to Dr. Laura. I don't know if any of you ever listened to Dr. Laura, but it's funny, when I was going to HVAC school, actually when I went to school, my own experience in trade school, I would listen to Dr. Laura Schlesinger all the time. And it's kind of a funny thing for a teenage boy to listen to. I was actually 16 and 17 when I went to HVAC school, graduated high school when I was 16, and would listen to her all the time. And it's interesting because I was interested in a girl who would later become my wife, and she would always talk about how you're not engaged unless you have a ring and a date. That always stuck with me about Dr. Laura. But enough about Dr. Laura. That's not what today is about. On today's podcast, I talked to Alexander Figueroa, and Alex or Alexander, whichever you choose. He is a technician down in Puerto Rico, actually, and he works on refrigeration and then also a lot of VRF systems. And so we actually had a little bit of technical difficulty connecting, and so we had to reconnect a couple different times, but we just sort of have a meandering conversation about VRF, his experience with it, some things to look for if you're ever going to work on a VRF system. It's nice to always get sort of a technician's perspective, somebody who's been in the field. We already talked with John Chavez previously about VRF and ductless, and obviously John has done a lot of that, but he has a consultant's mindset about these things, and that's very useful. But I wanted to just talk to somebody who works on the stuff day in and day out, and that's what Alex provides us. So I hope you enjoy this. Here we go, Alexander Figueroa. And Alex is an experienced refrigeration VRF guy, hails from New York, but now lives and works in Puerto Rico. I find that interesting. I know so little about Puerto Rico, so I'm gonna ask you a few questions about that as well. But just to start with, if you wouldn't mind telling us a little bit about you and how you got started in the business.
Yeah, okay. I've been about 15 years experience. I started as everybody starts as the grunt installer, making holes, putting line sets and mini split installs, and then I got an opportunity to work for a contractor that does refrigeration. And then after that contract was over, I got the VRF deal. So I basically work like subcontractor. I'm not a business, I'm just a technician. So I worked on various phases of it, from piping to starting up to wiring to, for the whole application. So I'm pretty knowledgeable about it.
Got it. So I guess the first thing is VRF is what it's commonly called nowadays. And that would be like, for those of you who install, because I mean, a lot of people probably who listen to this aren't going to know much about VRF because it is fairly new, especially in the States. If those of you who install ductless systems, it's very similar to that, similar technology, but there are some key differences.
Yes, you have a variable refrigerant flow. That would be the acronym for it.
Variable refrigerant flow, right. So some people will still use the term VRV, which is kind of an older term, and that's for the same general technology, which stands for variable refrigerant volume. But in general, we're going to use the term VRF.
Okay. It's mostly electronic. Most of it EEVs, electronic expansion valves. It works. It's pretty odd sometimes for a normal person that's used to a residential system, like a small central air. We work a lot of mini splits here. And ductless mini splits, and also there's central air in commercial buildings and such. Well, it's not common to see it in homes.
Right.
So most of it's ductless and ceiling mount, wall ceiling, type of units like that.
Right.
When you would go to the VRF, VRE, mostly the people that are using is commercial buildings, restaurants. The first project I was involved in was a 200 or 300 ton project. So which they did, they separated into the whole, it was a factory, a production line. So what they did, they would separate it into 20 or 40 ton sections. And they would hook up, some would be with fan coils, others would be cassettes, and they would combine to get the total tonnage.
Right.
So it's like putting a puzzle together. It's like if you would put a puzzle together. And also, there's software that helps you design these systems. I'm going to give you the example of the ones I work with personally. I work with many people that are overseas. They'll be familiar with Mitsubishi Heavy. They're Japanese. Everything's Japanese in it. And it works just like it has their designs. And there's other companies that do follow, and they have their particular design for each. But the concept of variable flow stays the same. All the makes and models. I know there's a lot of question, a lot of intrigue because many people just don't understand. But like me coming from the refrigeration side, it was easier for me to grasp the ideas of how the whole system worked in general.
So a ceiling cassette is essentially like a vent almost that's also an air handling unit or fan coil.
Yes.
So the other type of air handlers that you work on, are they generally like pancake units that sit up inside a ceiling space?
They're like a fan coils, like the pancake units, something like that style.
Right.
So what we do is to get the max airflow for the CFMs that we need for the tonnage. What we do is that we can actually pancake them together, 2 up to 3, 4 units together.
Okay.
And at the discharge, we will make a big duct for it, a big scoop, and it'll scoop all the air into the ductwork. That's how we use it for our applications that we use it in. That's how we were doing it now. So
interesting.
And it's worked. So, but for maintenance, it looks weird because it looks like when you give maintenance to it, you're gonna go up to we make a box. It looks like a locker type, and we insulate it with panels, and we make an access door.
Are those the two types that you generally, with VRF, you're not generally doing like wall hung units then?
Okay, wall hung if the situation requires it, but most of it's the cassettes and the fan coils.
Got it. With VRF, you're generally dealing with branch boxes, correct? So you're going from the condenser to a branch box and then to the air handlers.
Okay, in these particular ones, some use branch boxes. Here they're like copper Ys. And that distributes the flow. When you design the system by the blueprint, it gives you the Ys have a classification number to it, like a part number.
Right.
And you would use each one in the blueprint. It'll tell you which one to use, so it'll divert the flow.
Got it.
I'll give you the example for the 60-tonner, 2 30-ton units together. We would put them to one main, one common suction, one common liquid, and then you would use the Ys to put them to one, go into the building, and then from there, you would use the different Ys to connect to your handler or cassettes or whatever you want to connect to.
Right. Yeah, so one thing I want to point out to those of you who haven't worked on it before, there are primarily 3 different methods of metering flow. In a lot of residential ductless systems, they actually install the metering device at the outside unit. Which when you do that, you don't have a liquid line. They're both cold lines. One is
Yeah, they're both cold lines.
right.
Yes, that's true. I forget.
The one smaller line we would call an expansion line because it's actually flash gas inside that smaller line.
Yeah, that's correct.
And then you have to insulate it. But in VRF, you really have two different technologies. Either you have a system where you've got a branch box and the branch box has the actual metering devices inside the branch box.
And here you would take from the condenser, go straight to the units. Because the units have expansion. They will have EEVs, each one's.
Right inside the air handler fan coil itself. Cassette has its own EEV inside of it. So it's all a question of where that EEV is located. Generally, most modern ductless VRF, VRV use EEVs. That's pretty standard because that's part of the variable flow kind of side of the equation, right? I mean, you have to have something that can vary the flow.
And also not the funny part, but some people think this is crazy, the way I'm going to say it. But actually, we don't use heating, but in these systems, you actually will have proper oil return. The machines will switch into different intervals. It will switch to heating to aid for the oil return. But when you're starting up for the first time, we'll go into heating mode you'll hear the oil shooting through the lines. And then you'll hear the compressors turning on. Then it goes into heating because you'll touch the condenser outside. It's cold. About a minute, 2 minutes, and then you'll hear the swish from the reversing valve, and it goes into full cooling.
That's something I'd never heard of before.
I know. I tell people that, and they say, "Oh, it goes heating or cooling." I said, "No, it uses that particular brand uses that, and it'll pump down after if it cycles off on temperature, and it'll go through the heat cycle again to bring all the oil back." And to return it. That's why most of them have oil separators and accumulators in the condensing.
Interesting.
The higher one, the higher tonnage, not the smaller tonnage. The smaller tonnage has a very big accumulator, but the higher tonnages do have separators with oil.
Well, and it makes sense that oil would be a concern in the same way that oil is a concern in refrigeration. It makes sense that it would be a concern in VRF because you're dealing with very long runs of copper, unlike, residential or even commercial typical split systems where you're only going to a single handler. You don't have as much copper, and so you don't have as much oil loss. Whereas when in a VRF system, when you're running separate copper lines to every single point in the building, you have copper running all over the place, and oil return becomes more critical.
The interesting part is that sometimes in the smallest diameters, you could run 300, 400 feet.
Right.
With no problem. Secondary, sometimes when you have to trap after long vertical drops, in the VRV, it's not necessary to have the traps. In design-wise, it's a lot of different people that are not used to seeing something different. They're like, why is it like this or why is it like that?
Right.
Because it happened to me when I started doing it. But if you have a refrigeration mindset, you won't have no problem with dominating the basic skills.
Yeah, and so the first thing that we're pointing out is where the metering device is located, because after the metering device, it's no longer liquid line. So if the metering device is in the air handler, the electronic expansion valve is in the air handler, then it's liquid line all the way to the air handler. If the expansion valve is in the branch box.
And it's insulated.
Correct.
And it's insulated. That's supposed for the heat.
Oh, true.
You see people like, oh, superheat, subcool. It has electronics. The electronics do everything. It finds a target. And like I was telling you about the multiple systems that we have, that we sandwich the blowers, sometimes when the room gets to its temperature, the electronics will actually close the EEV completely on one of the 2, 3, or 4 that you have blowing, and to cycle it off. So it's not like a normal, you hook up a computer, there's a program with an interface, and it tells you everything that's going on. So sometimes you see, what got me puzzled was you see people that go superheat, subcool. You're going to see some with lower, higher, lower, depending on the load that you have and the ambient outside.
Right.
It's hot all year long here, so it's about 85, 90. So the numbers stay a little bit constant.
Right.
But the electronics actually do all the guesswork for you.
So even when it comes to charging, the actual interface is telling you whether or not you're low on refrigerant or what you need to add or that sort of thing?
No, you would actually see it takes a little bit of when you set up the system, if you follow the blueprints, on the machine, when you open up to the wiring, there's a table, in my case, the ones I work with. And you have to measure all your liquid line lengths by each diameter from 1/4 to 7/8. And it gives you the formulas, to add the additional charge. When you do it by the program, you put all the measurements into the design program, and it tells you, okay, you're going to put additional X amount of pounds for the system.
Well, initially that makes sense, but what do you do if you ever had let's say you had a leak somewhere that you then had to recharge? How would you do it at that point?
A leak, nobody's going to recover. Sometimes these long systems take 200, 300 pounds. I mean,
right.
I say the way I've done it was, I know some people, sometimes they go say it was this way or that way. Like I have constant ambient. I would go by a saturation temperature, and I would know more or less. And also I could put the machine, like it varies the speed. I can put it in full speed. There's a way for me to put it in full speed. And I can check in full speed. Any problems.
Like max capacity, basically. Put it in max capacity and then...
Yeah, the neat part of it is I can go to 130%.
Right.
Of capacity. Your downside, that compressor is going to be screaming all the time.
Right.
And the fans are going to be screaming all the time. But noise-wise, it doesn't make a lot of noise. It's like the ductless. It doesn't make a lot of noise. It makes no noise. You can hear it revving down. When the room's getting to set point, you hear it looking for its balance.
Right.
The part you said about the low chart, here's the funny part. Let's just say if I had 3 or 4 units connected together, like a cassettes or fan coils or walls, when I be running low on charge, the system will use the temperature outside and it will rev the compressor up, trying to look for my ideal suction.
Mm-hmm.
And maybe some of the units you'll feel like if it's a fan coil, like it's long, you'll feel half of it cold, like an expansion valve that doesn't fill up.
Right.
You'll have half of it cold, and you'll have half of it hot, like if it was in heat mode. The reversing valve will slip a little bit, go into heat mode to get that suction up, and then it'll close back again to go up and down. So it's pretty inconvenient. So you have to be familiar with some things that some people look at it and say, why? Those are things that I learned from it, working on them.
Cool. All right, so let's talk real quick about additives into the refrigerant system. Let me give you a blanket statement first. The blanket statement is that I'm not a fan of putting aftermarket additives inside of an air conditioning system. I'm just not. It's not something that I like to do. However, there are cases in which additives are a good idea, and the perfect example is when the whole situation happened with Copeland and the rust inhibitor in the compressors that was causing issues with expansion valves. A lot of manufacturers came out and actually gave part numbers for high-performance lubricants to put in the system. And the Carrier did this, and I think some others did as well, in order to help combat this problem with the rust inhibitor. And clearly, rust inhibitor in and of itself is also an additive. So there are already additives being put into systems in many cases by the manufacturer. And generally, I agree that the manufacturer probably knows what's best to put in their systems. But there is a situation, a circumstance in which I'm having my mind open to, we'll put it that way. And that is the use of leak sealants. Now, before you freak out, there's a specific type of leak sealant that I will never use. And that is a leak sealant that hardens inside of the system. Those are leak sealants that react to air and moisture. They're often called refrigerant-based products. They travel with the refrigerant, and when they hit air or moisture, they harden. And these products can get into your TXVs, they can get into your compressor, they can get into your gauges, and they'll try to sell you on the idea of adding extra drying agents in order to get moisture out of it. I'm not into any of that stuff. I don't want any product that's going to harden in my gauges and potentially damage my tools. But I have tried out the RectorSeal Leak Freeze product. This specific product, it's different than the other products. It's an oil-based product, so it actually mixes with the oil. It's a slower sealant. It doesn't act in 10 minutes or something. And it creates like a scab inside the pipe on very, very, very small leaks. So when you talk about champagne leaks, a lot of people call them, or formicary corrosion leaks. Cases where you have systems that are 10 plus years old and they have very small evaporative coil formicary corrosion leaks, we've seen it work really well. It doesn't damage your gauges, it doesn't harden, it's not going to clog TXVs, it doesn't react with oxygen, it only reacts when going from the system to atmospheric pressure outside of the system. Now, a lot of people say, well, just find and fix the leaks. We're talking about a specific situation here. Obviously, if you have a rub out, then you find and fix it. But if you have an evaporative coil with a formicary leak on an older system where the customer isn't going to pay to replace the coil, in some cases it may work for the customer to use a product like Leak Freeze. And I'm just telling you, we've tried it several occasions now, and I've actually been surprised at how well it works. We had a situation where the system was actually dropping pretty quickly, but we knew that it was small formicary leaks throughout an evaporative coil. We added Leak Freeze, and it greatly reduced the leak rate. So It's something that we offer to our customers. We don't tell them it's going to work. Some people say, well, how can you sell something that you don't know is going to work? Well, just by being honest with the customer and say, hey, look, we'd be happy to put in a coil. We'd be happy to replace the system. But if you want to try this, you can try it. And if it doesn't work, worst case scenario, we'll take it off the price of the repair or the replacement. That's what we do. I'm not telling you that's what you have to do, but it has actually been working pretty well. And I am the biggest skeptic when it comes to additives, but we've done our testing and I feel pretty comfortable with it. So that is RectorSeal Leak Freeze. You can find out more by going to rectorseal.com. So what are some things about it that an average technician, when they first start to work on it, can maybe be easily confused by?
The charge part you said about?
Or just anything related to a VRF system. What are some things?
Anything charge related. You don't have compressor problems. That's very rare. Usually the system has electronics. They'll give you the alarm for compressor and you would go look in the troubleshooting book. What would I do? What would I go? Or the steps to take.
Right.
But as long as you follow the instructions, you follow your blueprints, you do all the general safety, raise of your nitrogen, and your good vacuum, you shouldn't have a problem. When I get impressed is that when you open it up for the first time, you see all the solenoids, and that's what didn't afraid me was coming from a refrigeration background. I've done supermarkets, so I understood the concept, so I wasn't uneasy about working with it.
Right.
Somebody that's not familiar with refrigeration, like special applications, you could get like a little scared about it, but once you get a hang of it, common sense and good practice, that's what. I'm not saying it's going to fail, but.
So one thing that I've seen or heard of are 2-pipe versus 3-pipe systems. And where you are, obviously you don't have much heat, so that's not the primary consideration.
So I use the third one. I don't use the third one. The third one would be like for hot gas defrost, hot gas bypass. I don't think it'll be used here without the ambience don't go out that low. We use the 2-pipe a lot. You
would use a 3-pipe in a case where you had some units that were calling for cool and some that were calling for heat. So you could provide heat to some units and cooling to others, I guess, is the reason for the 3-pipe system.
Yes, that's correct. Yes.
And I know even with a 2-pipe system, there is a way that some of them utilize branch boxes in order to use diversity within a space, so that some areas that are absorbing heat and some that are rejecting it in order to actually take the heat into the branch box and then redivert it. So there's actually some technologies that exist. And the way I think of it is almost like a energy recovery ventilator, only for refrigerant.
Yeah, so heat reclaim, or in rack systems, these are heat reclaim. It'll work with that concept. But here we don't get the ambience and not that low, so we don't. Not even in the mountain region, they'll get that cold. So
right. Yeah, it's really interesting stuff, though. But I think the main thing that technicians who are coming from residential or light commercial have to get used to on the air conditioning side when they're working on refrigeration, if they're going over to VRF, so the system has shared resources. It has shared refrigerant and it has shared compression. And that's then being distributed to multiple locations throughout the building. But it's not, we're always used to in residential and light commercial air conditioning, we think you have one compressor, one condenser, one metering device, one evaporator. Well, in this case, you have one compressor, a lot of refrigerant, one condenser,
and a lot of evaporators.
Right, exactly. And then a bunch of different evaporators and metering devices.
The number that you can hook up to this, the max number of this, it's 150 units. Given you don't pass your capacity, the capacity, the tonnage, I think it's 85-90% of the tonnage you can go to.
What type of compressors are these using mostly? Are they large rotary compressors? Are they scrolls or?
No, they're full digital scrolls.
Okay.
And in my case, in those Mitsubishi heavy ones, they're Mitsubishi branded. These things are made in Japan. They have Japanese labels all over it. So, but the instructions do come in English and in more than one language. But mostly when you open the top up, it's the label of the compressor is all written in Japanese. And it says made in Japan.
All right. So for people who are coming into VRF, looking at it for the first time with the technology and all that, what are some things that you would suggest to them to kind of get into it without getting overwhelmed?
Most of the times, but in my cases, the ones I've worked on, you can get really confused because of the electronics and stuff like that. But it's nothing overwhelming. I mean, just basic knowledge would help you understand it. Like I said, good brazing practices, good flaring practices, the usual as of good installations. It can throw you off sometimes because you think you have a low charge, but probably it's modulating. And there's charge-wise, it throws people off a lot.
And so are you generally looking at the user interface?
Mostly the ones I work on, we have a design software for it. The machine itself has a table that we just add up the lengths of the liquid lines, and it'll give us a idea of extra charge, what we have to charge in, weigh in the charge when we start it up. I know the times that I've lost the charge were smaller units, not the really big ones. So, rule of thumb, what I would do is that it has a test mode that you can put it in 100% speed, the compressor, and I would check the room temperature and go from there for a ballpark figure. But the electronics usually do the rest.
And on a lot of these systems, you can monitor superheat and subcool for the individual air handlers, can't you?
Yes, you can. On the controller, it'll let you see the superheat and subcool for each one, and it shows the electronics looking for and the actual value. So they're very close.
Which isn't going to tell you a lot about the overall system charge because the charge is shared, but at least it will tell you that that particular head, that particular air handler is doing what it's supposed to do.
Usually the superheats and subcools are really high on it. Being a variable system, it takes an eye sometimes for other things.
All right, so for a new technician who's working on a VRF system, are they going to walk up to the piece of equipment and connect gauges to it, or is that pretty much generally going to be done through the interface?
No, yes, you can connect gauges at the condensing unit. You can connect the basic set of gauges like a pipe system, like a common system. Like if you were to hook up to a supermarket system on the main manifold, the VRF would have the same idea.
Yeah, and I guess that's a lot of it is you have to think in terms of everything manifolding back to a single point and kind of thinking about either individually working on heads or working on the entire system as a whole.
Mostly you would work with your common suction, common liquid, because they have various ports for you to hook up.
And what are some common maintenance things that you would do on a VRF system?
What we do mostly is like keeping condenser coils clean, keeping the evaporator coils clean, making sure connections are tight. The signal wire for the communications, check the state of it, are not rotted or pitted or different things like that. That's what I check mostly when I do the maintenance with the contractor I work with.
And what are the most common failures that you see?
Most of it's electronics because we have bad power here. Inverter power boards can go, or a wire can burn out and short something. Compressors, very, very rare. I haven't seen one yet, but I've heard places that had compressor problems, which is mostly the inverter power module.
Yeah, I haven't seen very many compressor problems on.
If you do have bad, like from the grid, if you have bad power, it nuisance trips sometimes the units, the power modules. But nothing big I've ever seen, like burnout or something like that.
How do you relate VRF to commercial refrigeration? Because I know you do both. How are they similar and how are they different?
Mostly what helped me on the refrigeration side. Like I'm pretty good with refrigeration. Like, the piping, I didn't have no problems understanding how the pipe systems look. And usually the bigger, the larger systems, they have oil separators, they have accumulators, so I'm used to seeing that in a refrigeration environment. And it works just the same.
So I guess there is a lot of similarities between the two because you have common manifolds, refrigerant, you have common condensers, you have common compressors, and you're really only working with separate evaporators and expansion valves then, and controls, blowers, that type of thing.
Yes. Well, the subs that we use are for server rooms. And what we do is, like I mentioned before, we'll estimate the tonnage, and you can hook various blowers together for one duct to get more CFM out of it. So that's how we get the most volume of air out of them. Because we could put 2, 3, like the pancake style, we could put them together and put all 3 of those discharges into one duct, and we'll get a good volume of air. Because that's what those most of those rooms need, cold air.
All right, cool. I think that mostly wraps it up. If there was somebody who wanted to get into VRF, what advice would you give them?
Get familiar with your equipment. There's a lot of read. Don't be scared of asking somebody. I think reading, that's how I refine my skills. I would read a lot from the manufacturers. Get their service manuals for the equipment if possible. Even though if it's an older model, most of the electronics stay the same, but they change up just sometimes designs and other details. But most of it, if you can get a service manual for one generation, it could help you for various units of the same brand.
Yep, that's great advice, especially because in VRF, like in ductless, there's a decent amount of variability between the different manufacturers, the way they do things. So it's good to not only know the general information, but the specifics of that particular manufacturer, the best practices.
I can give you an example. For the Fujitsu HFI, the Helicon inverter one, the multi ones, you have to have at least 3 units connected to it. And the 3 units have to sum amount of BTUs. So sometimes that's the only limitations to the system it has. And the condenser is 48,000 max. So you can put up to 8 units for 48,000. So that's the limit caps on it. And that's what makes it a little bit more, every manufacturer, like you said, specific with the limit cap. So you have to be very, very specific, meticulous of how to choose and what system to use.
Yep. And that's similar even, like even in ductless, you have to have a minimum line length and then you have a maximum line length in order to accommodate the refrigerant charge in that system for the different modes, for the cool and heat mode. It's interesting. It's important to read the stuff. Otherwise, you would never know that.
I know the ones that I work with, they have a small 5-tonner. It looks like a suitcase. And they'll bring enough refrigerant without changing the line set diameters for 100 feet. So with the factory charge, I can use 100 feet of piping without upping diameter. And after 100 feet, it has a formula on it that I determine how much charge I'm going to put into it, extra charge.
And there's no way you would know that unless you read that specific manufacturer's details.
It's on the condensing unit when you open the service it. In this case, you will go to the back of it, and the label tells you how to do the service test and pump down without putting gauges on it. You can pump down. You press the button on the board, and it'll go into pump down mode. And at the side, there's another sticker explaining how to do the additional charge, how to compute it. It's really simple.
Cool. Well, that's another thing. Reading stickers on the units themselves, you can also learn a lot doing that.
They'll give you some of the common errors, the error codes, most of the common ones. Not all of them. You have to get the list from the manufacturer, which is the one that we use. I keep it on my phone just in case of so much of those units we run into. That's what we majorly install and service. We have one brand specific that we service and install. And the other side brands, off brands that we install, but we don't install as much as those. We do the VRF.
Well, very cool, man. Well, thanks for coming on the podcast. I appreciate your perspective, doing it where you do and the circumstances that you do. It's kind of cool to have somebody who's from a whole nother part of the world than some of the rest of us. Yeah, thanks for doing it, and I'm sure we'll get you on again sometime.
Anytime. You just let me know, and we could do it.
Yeah, thanks for listening to the podcast. Thanks for hanging with us. If you're somebody who's listened since the very beginning, I really appreciate you. I've never expected that HVAC school would grow as fast as it has, and my commitment is to make it better and better. And one thing that I think I've learned over the last few months is that when I get off topic, when I talk about things that aren't kind of core HVAC topics, either like we did today, where we are talking about some things that you would want to know when you work on a VRF system, or actually just kind of sitting there on the mic, me and Jim or me and Jack Rise or one of those types of guys, and just talking through some of the core technical things you need to know. Whenever I get off base with that, I think I lose some of you. So I've kind of doubled down on doing technical training here on HVAC School. However, we do have some other podcasts, some other options that you can listen to in the Blue Collar Roots Radio Network. Blue Collar Roots Radio Network. Did you catch that? Blue Collar Roots Network. And those are HVAC Shop Talk with Zach and Ralph. It's one of our early podcasts, one of the founding members of the Blue Collar Roots community, and then also the Tradesmen. And we have several others that are coming online as we speak. So if you want to pay attention to that, the website is going to be bluecollarroots.com. By the time this comes out, it may actually already be up, but just keep an eye out for that. That's bluecollarroots.com. And thank you for doing what you do. Thank you for being out there and doing good work every day. If you work on ductless systems, then you know they can be challenging to maintain. And if you don't work on ductless systems, then you're just going to have to take my word for it. The fin spacing on the evaporator coils are very tight, and even actually the condenser coil fin spacing is also tight. And then they also have these blower wheels that are really long, and the cups on them are just tiny, and they tend to gather up gunk over time, and they just stop working efficiently if they get dirty at all. They get any significant grime on them, they stop working properly. So the challenge is with ductless is how do you clean them? Because often ductless systems are, they're mounted up on walls in places that you can't get water all over the place. So how do you clean them properly? And one way you can do it is you can pull them all apart. You can pull the blower wheels out, but even then, if you do that, you still have to worry about how you clean the evaporator coil. So what do? Pull the whole air handler off the wall? Well, never fear. RectorSeal makes the Dissolve kit, and it's the word dissolve without the E on the end, as is very popular nowadays, to omit the vowel. So it's a Dissolve, and it's a kit. It's also a cleaner, and so they have a cleaning solution that you can spray on the evaporator coil and blower wheel. But then it also has this bib that mounts underneath the air handler or fan coil, whatever you want to call it, and you can actually use a wand to clean that off, and it all funnels down into a bucket. And what's nice about the kit is that because everything fits inside the bucket, so you just keep the bucket on your truck. You've got the bib, you've got the little drain that drains down into the bucket, you've got the cleaner, you've got everything all there in one place. So it's a pretty cool kit. Check it out. It is the RectorSeal Dissolve Kit. Also, if you work on ductless, one thing that a lot of people struggle with is this idea of testing performance on a ductless system, because checking the charge is really tough on ductless. I mean, you can tell if the thing's flat, but other than that, it's tricky because there's so many moving parts. But what you can do pretty easily on most ductless systems is you can get a chart that shows you the different CFM output for the different stages of operation. So what did the I'm doing this shamelessly this time. I'm not even trying to lead in. So what did the grape say when it was stepped on? Nothing. It just let out a little whine. That one was even below me, I think. We'll talk next time on HVAC School.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.